Once you've learned how to make top hats and how we're going to get round pipes and ducts, bearing in mind that the method of a top hat can be any size or any shape. Little example here. So this is the standard penetration where we've made a top hat to fit around a pipe that's coming through a floor. But bear in mind, we're going to have penetrations potentially floor, walls, roof, and anywhere, any shape, any design. So therefore, this can be adapted to fit anything. What we've got here is this simulates a RSJ, a steel joist, a beam. We could use a similar method to seal round the steel. It could be any size or shape steel, or could just be a glulam beam. But once you've learned the process of using a top hat, you can adapt that for almost any situation. This comes particularly useful in retrofit, where you've got existing steels, existing timbers and beams, and joists. Okay, windows. That's what we're going to approach next. What do we do with windows? Airtightness around the windows is key. We've spent a lot of money and a lot of time researching windows and establishing which ones it is we're going to use and why we're going to use them. We use a particular product. We fitted the windows. We've got them in with the insulation and brackets, and it's all been filled very nicely. We still have to airtight it. There's no point in having a really good quality window with lots of seals and thermally efficient and everything else, and then we don't airtight it. The process of airtightness around doors and windows, a few key things to remember is now around any door and window, there's going to be a gap because there'll be an insulation around it. That will be your backing for taping onto. We treat doors and windows exactly the same. There's no difference, just different sizes and shapes. Every reveal is going to be treated in the same way. Once you get a standard way of working, a standard design, and get used to working that way, you'll repeat that process time and time again on doors and windows. This could also be loft hatches. The process itself doesn't change. It's just what we do. What we do is what's important, and that's going to be the same on every reveal. We actually lap onto the window. We lap onto the door, or whatever frame that we're air tightening to. We're 8 to 10 mil. We try not to go onto the window, door, or frame any more than that, because otherwise, when the reveal has been finished off with your plasterboard or insulation, or whatever it is you're bringing into the window, you could potentially see the tape. We don't want that. So 8 to 10 mil onto the window and nice and tight into the corners. So we push into the corner and we go onto our airtight tape or membrane or whatever it may be. Bearing in mind that the corners are the most likely areas to leak. If you're going to get an air leak during an air test, 90% of the time it will around a window or a door. And that's because of the corners. So pay particular attention to how you put a piece of tape in the corner. The best way is actually to have 2 pieces of tape and then filling the corner in afterwards, taping another bit over the top. Then that way you're paying your attention to detail. You're paying the attention to that one area. And that's where your attention to detail will come in. Also, brackets. Fixing brackets of any door, window or frame, they will also need to be airtighted. In other words, simply taped over to make sure that there's no air leakage around our brackets, as well as around the window, door or whatever frame it is we're fitting. Liquid membranes. Liquid membranes, very, very good. They're very useful, especially in retrofit where you've got an uneven surface or you've got something which is already existing, like we were showing earlier with the RSJ or a joist or something going into the wall here. It can be painted on, it can be sprayed, either one. It could be painted sprayed over any gap. We could also use it externally of a build, especially in a retrofit where you want to airtight a surface. It could be painted or sprayed. Here we have some brackets fixed to a wall, and it's actually been sprayed on around the base of the brackets. So every screw and every little crack in the brickwork has been filled with a membrane. The great advantage with this as well is also you can get a combination of different methods to achieve what you need. In this case, this is a liquid membrane. Once it's set, you can tape onto that. So if you wish to get an overlap with a membrane and tape onto it, you can do that. So we can get a good combination of products to get the best result possible. Liquid membranes. What are the types of air tightness barriers of which are not typical? Well, these are things we will look at. People will say, you can't have this, you can't have that because you're in a passive house. Well, these things can be airtight already, especially in retrofits. Concrete cast in situ. Once you cast a piece of concrete, the depth that's going to be required structurally will also give you your airtightness. And this is precast concrete, where you've got precast walls or you've got precast floors, which you often get, and you crane them in position. Now, the panels themselves will be airtight. It's just in between those different panels, you're going to have to concentrate on making sure that the airtightness is done. Screeds. Now, I think the minimum screed you go to do these days is about 70-75 mil. That in itself will be an airtight barrier. We don't rely on it. We don't rely on any of these. The screed itself could potentially crack at some point. It's unlikely, especially with modern day screeds, but we usually airtight outside as well. But these can be considered on an existing retrofit as an airtight area. Wet plaster. Now, what we mean by wet plaster is a typical thistle or powdered plaster, normally put onto about 3 mil. 3 millimeters of plaster isn't considered an airtight layer, isn't considered an airtight barrier, even though it's very good at resistance. Up to 5 mil in depth. If we can go to about 5 mil in depth with plaster, with wet plaster, in other words, what you see the plasterers put on with their trowel, up to 5 mil thickness, that can really contribute to an airtight layer. Damp-proof membranes such as polythene sheeting or visqueen, or what we use for damp, anything usually that we would use a poly product for, which would combat moisture or damp travel, anything that's going to create a damp membrane is usually also very good for air tightness as well. The only thing is you have to double check on the tapes that you're using to make sure that the overlaps are correct and the seals are done. But many polythene products and poly products are actually really good at air tightness and can be used and are used, especially in floor areas. Products that are commonly used but do not form robust or reliable air barriers. Right, many times people have tried to do shortcuts or use materials that they've got already instead of using the proper materials to get the job done. All these are things that have been used and people think they're airtight, but the problem you get with them is they break down, or they don't have the adhesion properties that they need, such as duct tapes. They're really good at what they're designed to do. They are not designed for an airtight barrier. Aluminium foil is just too weak. It will not take the air test. Expanding foam. Expanding foam is a really good gap filler. We use expanding foam. It fills the gap. It's also got good thermal properties. It's quite a good insulator, but never rely on an airtight a foam to be airtight. Even airtight foams, once you use them, if you cut the back and cut through the surface, is no longer airtight. Do not rely on the foam as an airtightness, even though it's a good gap filler and a good insulator, and provides good backing for airtight tapes. Silicon sealants. Silicon sealants are an airtight liquid, and some Passivhaus construction methods actually recommend that is used. Personally, and by experience, we tend not to use silicon sealants as air tightness barriers unless it's specifically designed to do so. There are silicon sealants which are purposely designed to be air tightness liquids. Use those, but not your standard silicons, because if there's any dust or everything else, it will separate and not potentially get a good air tightness result. Decorator's cork. Decorator's cork shrinks, it moves. That's why we use it in decoration, because the whole idea is with a decorator's cork that you seal a gap, and it will seal a good gap up to 5-6 mil. The only difference is it's designed to move with the plaster and whatever it's put onto, and paintable. You paint over it, looks really good, but at some point in time it will dry out and potentially crack, and therefore should never be used as an airtight. Dot and dab plasterboard. Plasterboard should never be considered as an airtight barrier. When you dab and dab plasterboard on, you've got a gap at the back, which can create airflow, which in some circumstances is very good, but the gaps will always move. At some point in time, you're likely to get a crack in the joint, therefore no airtightness. So plasterboard, especially dab and dab, not airtight barrier. Skim finish, we've just touched on this with the skim finish, the plaster. The plaster rarely cracks, but 3 mil of plaster, which is standard, would not give you an airtight barrier. Up to 5 mil can be considered as an airtight barrier, but it's not something that we would rely on 100%. We would normally back it up with something. OSB board. We use OSB all the time. There's many different makes and types of OSB boarding, but never consider an OSB board to be airtight. At the end of the day, it's lots of them, bits of material put together with a resin or glue of some description. These potentially are not airtight. Vinyls. Vinyls are a good product for floors and everything, and areas. We use vinyls a lot in construction these days, but never use a vinyl as an airtight barrier. Too much movement, too much variance, and too difficult to seal. Plywood. Plywood comes into the same sort of category as OSB. Plywoods themselves are usually quite airtight, but we can never rely on them because it depends on the type of ply. Flooring. No type of flooring is designed to be airtightness. Floorings, laminate floors, that type of thing, including the vinyl floor, do not rely on this to be airtight. Always put another barrier under it. Masking tape. Masking tape, again, is for decoration. Nothing you use for decoration should be considered as airtightness. Masking tape, again, is designed to come off. It's not designed to be left on. So therefore, you put it on initially and paint and it seems really good, but eventually that will dry off and peel. So these are some of the things that people try to use for airtightness, but we never consider them to actually be airtight. We always back them up with something else. Testing. When we take our energy efficient, Passivhaus, whatever it is we're trying to do, we always do an air test, regardless of what the design is, the shape, or when it's built. We always do an air test, because it's most important to know that the envelope that we've constructed, this thing we've taken care over to make sure that it's airtight and it does its job. The only way to confirm that is to test it. Now here, we would test it with a fan. It's a frame which is put in a doorway. That fan would pull air out of the building, and that will make a negative air test. In other words, it will pull all the air out, and once the pressure is down to a given amount, it would be sealed off and then measured the amount of air coming back into the build. And as it tries to rebalance itself, and it is measured, and the amount of air over a given amount of time gives us the air test that we need. Also, on the same piece of apparatus, we can do a positive air test. We can pump air into the building and pressurize the build. And then once it's up to a certain pressure, again, this will be sealed off. And then we can measure how long it takes to repressurize to balance itself out. Exactly the same, but opposite to the negative test. This would give us a score. Now, there's a little sample here of a certificate being created to say that a build is up to standard. And they've achieved their air changes per hour at 0.6, is which we always strive to achieve. 0.6. That is our target to which we go for on a Passivhaus. Okay?